people in pre-cal, do y'all remember what that is? Reference angles?
Oh, okay, yeah.
Reference angles? What are they? Yeah, pi over 6 is one. Yeah, pi over 4, pi over 3. Those are all in what? Yes. So reference angles always in quadrant what? 1. Very good. So that means they're all less than what degree?
5 or 6.
Less than, yeah, which is 90. Good. They're all less than 90. And then the most common reference angles, and y'all already said them, the first one's what? The most common? Which is what degree? What is pi the same as? Remember we talked about yesterday? 180. So what's 180 divided by 6? Good. The next common one is pi over 4. And what's 180 divided by 4? Very good. The last common reference angle is pi over, which is 60. Good.
Oh, so you're not doing 3.14?
Nope. Pi, when you're talking about circles, is 180. 180 degrees. What we're gonna do is draw them over here, these angles. If you know this is 90 degrees, right? This is 0. 45 is what? In the middle. This is 45 degrees. And then half of that, between 45 and 0, is the 30 degree angle. And then half of that, between 45 and 90, is 60. So reference angles are always in quadrant 1, and it's all pretty much always going to be 30, 45, or 60. Yeah. I'll grab it. Today I'm going to teach y'all the hand trick, which some of y'all probably already know. But if you don't, make sure you're paying attention. Pass that back for me. Alright, your hand kind of looks like this first quadrant, your left hand. Everybody pick up their left hand and put it on their paper like mine. Okay? So the thumb represents what degree right here? 0. The index finger? The middle finger?
45.
60 and?
180.
Nope. 90. Good. And let's write that just so we don't forget. So the hand trick always has to be done with your left hand because that's what looks like quadrant 1. And also just remember that thumb is always 0, 30, 45, 60, 90. Alright, we are going to use that in a minute. The first thing we're going to do is find the reference angle for each one of these measures. Okay? This one's measure or reference angle will be in quadrant 1. And what measure or where is 240 at? Quadrant 1, 2, 3, or 4? Q3. Let's figure out the quadrants first. In Algebra 2 at TRIG. Go ahead and find 2 pi over 3. 2 times 180, then divide it by 3. Tell me what that is. Anybody with a calculator? What is it? 120. Alright, so 120 degrees. What quadrant is that in? 2. Very good. And let me just clarify. This is 180. This is 270. Alright, 5 pi over 4. Go ahead and figure out what that is. So what's 5 times 180 divided by 4? 225 is going to be in what quadrant? Very good. Alright, 120 is in what quadrant? 315? Very good. And 5 pi over 6, that's going to be how many degrees? 150? So that's in what quadrant? Quadrant. Very good. Alright, for each quadrant, finding the reference angle is going to be a different formula. Okay? For quadrant 1, that's already going to be a reference angle. So if it's in quad 1, that is its reference angle. Does that make sense? Like if you have 45 degrees, that reference angle is 45 degrees because it's in quadrant 1. If it's in quadrant 2, what you're going to have to do, the formula is 180 minus theta. 180 minus that degree to find the reference angle. No. That's for quad 2. For quad 3, to find the reference angle, you will do theta minus 180. So that degree minus 180. And then for quad 4,
Why would you use data versus minus 180 for question 3?
because all of these are bigger than 180. That's why we have to subtract 180 from it. And then for quadrant 4, it's going to always be 360 minus theta to find the reference angle. So for 240, that's in quadrant 3. So how do we find its reference angle? Subtract 180 from it. So what's 240 minus 180? Very good. Let's do one more together. This next one, 120 is in quad 2, so I'm going to do 180 minus 120, which is what? Very good. Go ahead and find the reference angle for the rest of them on your own. And again, they should either be 30, 45, or 60. Because in college they don't let you use it. All right. Solomon, what was the reference angle for number 3? What's there to figure out? How do you find the degree? Nope. What's this the same as? Nope. 5 times what? 180 divided by 4, which is what? And so it's in quad 3, so I would do this minus, which is?
45.
Good. Say that again.
Like, see, like 5, 5, and 4.
Mm-hmm.
I looked at that, I saw like 5 and 4 up there. It was 45.
Yeah, you can do that. Very good. Alright, Darren, what'd you get for your reference angle for number 4?
60.
Very good. Y'all stop me if I need to go over one. Brandon, what'd you get for number 5?
45.
Okay. And Kaya, what'd you get for number 6? Alright, any questions about finding a reference angle? Everybody's good. Alright, next thing we're going to talk about is the common triangles, which are 30, 60, 90, 45, 45, 90, which hopefully y'all remember from geometry, but if not, that's why we're reviewing it. You can mark that out. Alright, for which one is your 30, 60, 90? Which one's your 45, 45, 90?
The first one is the 30 is 60.
How do we know that the first one's 45, 45, 90?
Because it's crossing out hypotenuse.
Good. It has 2 of the same what? Angles. So this one we know is what?
The one on the right is the 90.
What's always across from hypotenuse?
The right angle. Oh, right triangle.
Yes, 90. This one's going to be what? Very good. And this one is? Very good. And you can tell because it kind of looks like these have the same angles where these they don't. Where's our 90 degrees in this one? Across from what? The hypotenuse. What do you think this one is? And why would you say that? It's bigger. Good. That's all I'm looking for. This one looks smaller, so we know this one has to be 30 degrees. Good. You're talking about the lines like this?
Yeah, no, like the double lines. I will put 30 2 lines.
Talking about right here?
On the,
Yeah. Yeah, we don't have to do that on these. That's not what I'm looking for. All I want you to do on these is you're going to be able to memorize all of these values. That's going to be your checkpoint. That's going to be not tomorrow but the next day is you memorizing this table. And I'm going to show you an easy way how to. First one, let's go ahead and identify what these angles are. Pi over 6. Good. Pi over 4. And then pi over 3. Good. Alright, let's start with sine of 30 degrees, okay? So here's where 30 is. We know sine is what over what? Yes, so we're looking for this side and this side, correct? X and X. And this is for sine. Do y'all know the hand trick already?
I know the hand trick.
There's a what?
There's a half somewhere.
Yeah. Alright, hand trick, go ahead and put your hand out. Which one's 30 again? Yes, put it down. Alright, this side is always going to be sine, this side's always going to be cosine. You can think C comes first in the alphabet, so that's what's come first here. This side's cosine, this side is sine. Okay? And then with your hand, with the hand trick, you always have to take the square root of your fingers. Okay, right now we're just focused on sine, right? So I'm just focused on this side of the degree. What is this side? How many fingers? Square root of 1? Good. Alright. And all of these values when you're doing sine or 60 is going to be over 2. So it's square root of your finger, which is 1, always over 2. And let's go ahead and do cosine since we're here of 30. That would be adjacent over hypotenuse, right? So we still have 30 right here.
Miss Horton?
Yes.
Hey, can we please have Ashley Panetta come to the attendance window for just a minute, please?
Yes, ma'am.
Thanks.
So this side of your thumb, always on this side, is cosine. So we take the square root of our fingers. That's going to be square root of, very good, and always over 2 our hypotenuse. So that is a 30, 60, 90 triangle. These will always be the values. 1 square root of 3, your hypotenuse is 2. That's where you got the 1/2 from. So sine of 30, opposite over hypotenuse is going to be what? Opposite is what? Hypotenuse. Very good. We're going to skip the 45 because we're going to come back to that. Let's go ahead and do sine of 60. So here's 60. What's the opposite of 60? Over our hypotenuse. Square root of 3 over our hypotenuse, which is 2. Alright, cosine is blank over blank. Let's go ahead and write that. What's on top for cosine? Over hypotenuse. Good. So let's look at 30 degrees first. What's adjacent to 30? Root what now? Root 3 over our hypotenuse, which is? So square root of 3 over 2. Now let's look at cosine of this 60 degrees. What's adjacent to 60? 3 is opposite. It's across from it. 1's adjacent over what? 2. So see how these flip-flop?
Wait, adjacent is what's close to it?
Mm-hmm. Alright, tangent is blank over blank. Opposite over adjacent. Good, so back to 30. What's the opposite of 30? 1.
Oh, 1 over 30.
So it'd be 1 over adjacent, which is 1 over what? Do you leave it like this?
No.
Multiply the top and bottom by?
So it'd be 1 over 30.
It'd be square root of 3 over. Very good.
Oh, you want to put the 1 outside?
You can if you want to. Alright, tangent of 60, that's right here. So again, it's opposite over adjacent. What's the opposite of 60?
Square root of 3.
Adjacent? 1. So it'd be square root of 3 over 1, which is just square root of 3. Alright, now for 45. So back to the hand trick. Which one is 45 degrees?
The middle finger.
Yes, so put it down. Alright, what two fingers does this represent? Cosine, this one? Sine, which they happen to be the same one. So we do what with our fingers for cosine? Square root, so square root of,
2.
and it's always over, good, so square root of 2, always over 2. For sine, wouldn't it be the same thing? Square root of 2 over what?
2.
Very good. Alright, let me zoom out some. So this will always, or zoom in, this will always be the values for 45, 45. Square root of 2, square root of 2, and 2. Mm-hmm. Why would what just be 2? The hypotenuse will always be like these fingers over 2. For 45, 45, 90, and then 30, 60, 90, the hypotenuse will always be 2 on both of them. Alright, so starting with sine of 45, does it matter which 45 we're looking at?
No.
Because they'll be the same, right?
Yeah.
So what is opposite of 45 degrees?
Square root of 2.
Hypotenuse. So it'd be square root of 2 over 2.
Wait, you said that hypotenuse was across from.
Yeah, the hypotenuse is always across from the right angle. For adjacent to this, what's beside it? Over. Very good. Alright, and we can just look at any 45 degrees for the next one, opposite over adjacent. So what's opposite of 45?
Square root of 2.
Adjacent.
Square root of 2.
So square root of 2 over square root of 2?
It's just square root of 2.
1.
Oh, 1.
Very good. Alright, flip your paper over. Don't look at it. I'm going to put my hand up here, and what I'm going to do is I'm going to ask you to find something of whatever degree I'm saying, trying to use the hand trick, okay? Alright, let's start with cosine. Cosine, so of 30 degrees. Cosine of 30 degrees. Don't look at your paper. It's going to be what?
Middle finger.
Square root of 3 over? Always over what? I'm going to write on my hand just for y'all. Always over 2. Square root of the fingers, always over 2.
Wait, you say it one more time?
Square root of the fingers, all over 2. Alright, 45 degrees, sine of 45.
Square root of 2 over 2.
Good, square root of 2 over 2. Alright, cosine
Of 60.
of 60. Cosine of 60.
1 over square root of 3.
Square root of this, which is what? 1 over, so a half. Okay? Bottom fingers are always what? Sine. Top is always cosine.
That's what's confusing.
Tangent is sine over cosine. We'll get to that tomorrow. Let's do a few more. And if you want to hold your hand out too, you can. Alright, sine of 30 degrees. 1/2. Square root of 1 over 2. Sine is always on this side. Alright. Cosine of 45 degrees. Good. Square root of 2 over 2. Sine of 60 degrees. Root 3 over 2. Good. Sine of, cosine of 60. 1/2. Everybody understand the hand trick?
Nope.
Okay. It helped probably if you weren't talking while I was talking.
You was going a little too fast.
I was going too fast? Okay, how about this? Sine of 30 degrees. Which side is sine? So square root of this. Square root of 1 is what? Over. So sine of 30 would be 1/2. Cosine of 30. Square root of what? 3 over what? 2. Good. Alright, one more, and then this is what we're picking up with tomorrow. Alright, think of this, sine of 90 degrees. If I put this down, how many fingers?
4.
Square root of 4 over 2. So sine of 90, 1.
What's that you
This side is cosine, right? This side is sine. This is 90. So how many fingers? Square root of 4? And always over 2, so it'll be 1. We'll start here tomorrow.
What's that you in your hand?
2.
That's two
Square root all over 2.
Oh, I didn't know that's really in your hand.
Make sure you come to your period if you